Hi, my name is Karen Quiros, and I am lucky enough to be the science resource teacher for the Chula Vista Elementary School District located at the Living Coast Discovery Center in South Bay, San Diego. The Living Coast is a small environmental education center, and we have sharks, snakes, sea turtles, eagles, and more. Today's experience is titled Innovation Inspired by Nature, Fish Edition. And we're going to focus on how fish have inspired scientists and engineers to work together to create things that help people live better. Animals and plants have been on Earth for a long time, and they have become survival experts. So when engineers want to make something new, looking at plants and animals is a huge help. This is called biomimicry. Fish have some really unique abilities. They can breathe underwater, they can swim fast, they can see well without wearing goggles, and much more. Do you wish you could have some awesome fish abilities? If so, please write your responses into the question and answer section. I have my friends Mr. Bruder, Ms. Bystrak, and Mr. Ramirez helping me out today. They will be answering some of your questions right away, and I will be answering others throughout the lesson. As we study about our inventions inspired by nature today, we have four main objectives. We're going to continue our study of biomimicry. We're going to explore examples of products inspired by the abilities of fish. And we're going to get to meet one of our newest members here at the Living Coast. We're also going to learn how biomimicry is helping engineers to solve a problem about wind energy. And finally, we will become mechanical engineers and build a device that was inspired by fish. So let's review. What is biomimicry? Biomimicry is when people use ideas from nature to solve problems. Scientists and engineers work together to study and then create new products that help people. During my last event, engineers, I talked about that they gave us some reptile abilities, which helped us to improve the designs of backpacks, shoes, and even search and rescue robots. Today, we're going to be focusing on some products inspired by fish. So first, we're going to become ichthyologists, or fish scientists, and look at some amazing fish abilities. Ichthyologists study different types of fish, their behavior, anatomy, habitats, history, and development. Then we're going to become a mechanical engineer, and we're going to build a fish-inspired product. Mechanical engineers design and develop machines and technologies that improve our abilities and also make our lives easier. Are you excited? I hope so. I think it's fantastic that we can look at nature and be able to invent things that can solve our problems. Let's go ahead and check out some examples of biomimicry. You ready to play a game? Awesome. So, fish have inspired many different products by engineers. And remember, sharks are a type of fish also. So there's many parts that fish have that have been inspiring, and we're going to focus on four of them today. Their swim bladders, which help a fish move up and down, their skin, their body shape, and their teeth. So I want to see if you can figure out which body part inspired these inventions. Here's our first one. Yikes, this guy has a problem. When we're young, we're able to lose our baby teeth and grow in our adult teeth. But what happens if we lose a tooth when we're an adult? Which body part of a fish do you think can help us solve this problem? Do you think it's their swim bladder, their skin, their body shape, or their teeth? If you thought teeth, you're absolutely correct. Shark teeth for specifics. Sharks can actually regrow their teeth constantly. And this is a mako shark's jaw. Mako sharks are really large sharks, and they mostly eat other fish. Now, their teeth are not held in as well as ours are, so when they take a bite of something, they might lose a tooth. So if they keep eating and they keep losing tooth, eventually they would have none left. However, they have the ability to constantly regrow their teeth. And sharks can lose up to 30,000 teeth in their lifetime. If I turn this jaw around, you can see that all of these teeth, there's many rows ready to replace. So it only takes 1 day for the next row's tooth to fold forward, so they always have a perfect set of teeth to eat. Now, scientists have been studying how sharks can do this, and they are going to be finding, or they found that we have similar genes or instructions in our body. However, after our younger years, we actually lose the ability to regrow them. So ichthyologists and engineers are working together to find out how we can regrow teeth as adults. That would be fantastic. Let's check out another fish-inspired product. In San Diego, a lot of people enjoy scuba diving. It's so relaxing to go under the water and just be able to see all of the amazing creatures here. Normally when people jump into the water, we have to use a lot of energy to keep our head above water to breathe. But when people go scuba diving, they bring their air and they also wear a special vest called a BC, or a buoyancy control device. The BC can be filled with air or it can release air. This device was made because it imitates a body part of a fish. Can you guess which one? What do you think? Swim bladder, skin, body shape, or teeth? If you said a swim bladder, that's correct. A BC imitates a swim bladder. It's almost like these fish have a little balloon inside of them that they can inflate and deflate to make them move up and down in the water. When it's full of air, they go up near the surface. When they have some air in it, they're kind of in the middle. And then when there's hardly any air, they're at the bottom. So if you can check out the fish behind me here, you'll notice that some are up at the top, some are kind of in the middle, and some are at the bottom. Now, I happen to have this amazing scuba gear here. So we have the BC, which is going to be the vest that can inflate, and then the air tank here. And what I can do, you'll notice that the vest is kind of inflated, a little bit of air, but if I push this button, it's a little loud, you'll see that the vest inflates, and if I was wearing this, would float up to the surface. However, then if I saw something really cool down below and I wanted to go down, I just push this other button and the air goes out of the BC, which means I would slowly sink to the bottom and be able to check out what's down there. So engineers who developed and they continue to improve this BC, they have been looking at fish and becoming super inspired. Now, fun fact, sharks actually don't have a swim bladder, but they do have fatty livers that actually help them to be more buoyant. And also many sharks are kind of near the middle or bottom of the ocean. So cool that we can imitate fish, right? Let's check out another way. Both Mercedes and Chevy car companies have created cars that are modeled after fish. Do you think that they were inspired by their swim bladders, their skin, their body shape, or their teeth? If you said body shape, you are correct. Mercedes engineers were fascinated by a boxfish, and Chevy engineers were actually inspired by a mako shark for sports car. Now the boxfish is interesting because it doesn't have that usual slim shape that helps fish move through the water, but they do have this really strong bony box-like structure that's needed for a car. So engineers thought, perfect, we can make a car that will move easily, be strong, and have lots of space. But guess what? They were wrong. It was not stable when they made it. And they went back and they studied the boxfish a bit more. They realized that they didn't include one of the parts that was making it most stable, the fish's fins. So the car never was sold to the public, but they learned a lot that helped them in their future models. Now, Chevy was a little bit more successful in their imitation of a speedy mako shark. The features of their mako shark car appear in the Corvettes designed in the 1960s and 70s. The sleek shape imitates the hydrodynamic body of a shark that's built for speed. All right, let's check out one more part that's been the most inspirational to engineers. This body part has helped Olympic athletes win medals, America's Cup sailboat win races, body armor is more safe, and surfaces actually stay more clean because of it. Whew, that's a lot of inspiration. So which part do you think inspired all of these innovations? The swim bladder, the skin, the body shape, or the teeth of a fish? The skin is correct. Well done. In order to help us understand this party part a little bit better, I'm going to bring out one of our newest members here at the Living Coast. And this is a baby horn shark. Now, this baby horn shark is only about 2 months old, but I'm going to go ahead and switch my screen so you can see it even better. So here is our baby horn shark. Look at how cute it is. So cute. We don't know if it's a boy or a girl yet because we don't find that out until they're about 2 years old. Now, it's only 2 months old right now. They can actually grow to be about 4 feet long, so this baby has a lot of growing to do. Horn sharks get their name because they have 2 sharp spines on their dorsal fins, right here and right here. And they sleep during the day, so if a predator is wanting to eat them, they see them laying on the bottom. If the predator comes and they try and take a bite with their mouth, yum, 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 they get a sharp poke right in their mouth, ow, and they spit out the shark, and this predator remembers, ooh, I don't like to eat that type of food because it hurts me. So it will protect this shark and others like it in the future. Now, speaking of protection, let's get back to the body part that has inspired so many innovations, the skin. You probably know that the skin of sharks and other fish is pretty important in protecting these animals as kind of a hard outer layer, like our skin protects us. However, as ichthyologists and engineers study these animals more closely, they also found that the shape and the patterns of the scales on the sharks have other important traits as well. I'm going to go ahead and adjust my shark view so that you can see both the shark and what the scales look like up close. So let me see if I can get this going here. Perfect. So let's go ahead and check out the baby shark and the skin at the same time. And there we go. So now you can see the baby and these amazing scales. So shark scales are called dermal denticles, and this means skin teeth. When you look at these scales up close, they look like many rows of teeth, and they're not flat. The ridges and the overlapping triangle shape help the shark swim faster in the water, and they also prevent bacteria from growing on them. So if I take my finger and I move it down the little side of the shark here, I can actually feel that its body is pretty smooth, but it also has a little bit of toughness to it as well. The smoothness allows the water to travel over the body quickly. So Olympic athlete swimming suits and the bottom of America's boat both have the pattern and texture of shark scales, and this made them extra fast. Also, body armor for soldiers is even stronger because engineers copied the layering pattern of the scales. Finally, the pattern of the shark scales also makes it hard for things to grow or attach to their body. So by copying the texture of shark skin, hospital surfaces prevent bacteria from collecting, and boats have many less barnacles attaching to them. It's pretty expensive to remove barnacles from boats to keep them working properly, so this saves boat owners and the fishing companies quite a bit of money. All right, so thank you, baby shark, for showing us how cute you are, obviously, and also for allowing us to be inspired by so many of your body parts. Okay. There we go. So, Mr. Bruder, I think right now might be a great time for us to check in to see if there were some responses to my first question about some abilities that fish have that our viewers might like to also view or have. Would you mind telling me some of the ones that they are excited about?
Of course, and we have quite a few, but I was wondering if you could answer a question first.
Absolutely, I'll try.
A couple of our viewers had a question. If you could define again what buoyancy means.
Ooh, buoyancy. So buoyancy is how we are kind of able to float in the water. I think that's the best way to kind of describe it, is how you're kind of able to float. Float is another word for it.
Awesome, thank you. So we have some comments from our friends at Olympic View 2nd grade, including they wish that they could see underwater, that they could camouflage as well.
It's hard to see right now under the water unless you have goggles, right?
Speaking of that, we have Tyler who said he would like to be able to swim fast and see clear without goggles, as well as Layla who shared that she'd like to be able to swim fast as well.
Oh, swimming fast, right? These shark swimsuits that the Olympic athletes wear, that's Michael Phelps. If you guys remember Michael Phelps, he wore one of these suits when he won his gold medal.
We also have some people who shared that they wish they could breathe underwater, and they wish that they had gills.
When you scuba dive, you actually feel like you're doing that. It's amazing.
And then our friends in Mrs. Kohler's 3rd grade class at Rosebank shared a whole bunch of cool things about wishing that they could swim like a fish, being able to breathe underwater, the camouflage one. So it seems like there's definitely a pattern in some of the abilities that our viewers wish that they had.
Well, they definitely have amazing abilities that we would definitely benefit from. They've already made us faster, stronger, healthier, and they've saved us money too.
Well, we do have a few more comments, but I know you have some more cool stuff to show us, so I think we'll go back to you.
Until later. All right, sounds good. Thank you all for those inspiring abilities. There's one more inspiring ability I want to explore. There's a problem right now that mechanical engineers are studying. They've come up with some pretty creative solutions, and they've done it by studying groups of fish. So let's check out this video.
Have you ever thought about how things work? For example, what makes it possible for us to watch this video? That's right, energy. But how exactly is energy generated? Just like you need to eat, drink and sleep to be able to wake up strong, everything around us needs energy. We get energy from 2 types of sources, renewable and non-renewable. One of these renewable energy sources is wind energy, which comes from the wind, a natural resource you can find all over the planet and that is never ending. So you may be wondering, where does wind come from? First, we need the sun. The same rays that make you tan in summer are used to heat up the planet. As the planet heats up, the air begins to be of different temperatures. Hot air tends to rise and cold air tends to drop. This movement of uneven air produces wind. So far, so good? Easy, right? Now the question is, how can something we cannot capture with our hands generate energy? When it is windy, we use wind turbines, modern mills, that transform the energy from the wind into electricity, which is what reaches our homes so all of our appliances and devices can work. Since the wind is a natural and never-ending resource, wind energy is a clean and sustainable source of energy. It reduces pollution as it doesn't produce any greenhouse gases, and therefore it helps us care for the environment and get the planet smiling. To achieve all of this, we need at least one wind turbine. They are called wind turbines or wind generators, and you see them quite often when travelling on holiday by car. The wind moves the blades, and as they rotate, they produce electricity. Now you know it. When the wind moves these turbines, you can turn on the lights when you get home, use your computers, and watch this video.
So now that we know wind energy is a type of green energy that can power anything that uses electricity, the problem engineers are trying to solve is that the horizontal wind turbines are huge. They can be up to 300 feet tall, and they have to be really spread out so they take up a lot of space. They're also located usually pretty far away from cities, so the electricity they generate has to travel really far. So engineers are wanting to build something smaller but still powerful that takes up less space. So to help them solve this problem, they looked to fish. Many types of fish swim together and they group in schools. Swimming together has a lot of benefits. So they're more safe because as a group, they look like a bigger animal, so predators will actually stay away. Also, when they swim in a circle, they're using less energy because the fish in the front leaves a pathway that's easier to swim in than going off on their own. Engineers noticed that by making the blades of the turbine spin like a school of fish could reduce the amount of wind and space needed to generate electricity. So, therefore, they created a different type of turbine, a vertical wind turbine. These turbines only can be 30 feet tall instead of 300, and they actually work better when they're closer together, just like fish in a school. So mechanical engineers are still kind of improving the design of the vertical wind turbines. So I want you to think about this. Are there any animals that you know of besides fish that move or live in groups? Maybe engineers could study other animals and groups and get other ideas for wind turbines as well. Go ahead and write your responses in the question and answer section, and I'll check back later to find out what animals might inspire the engineers next. Okay, are you inspired? I hope so, because now you are going to become a mechanical engineer and build a vertical wind turbine. To help transform us into mechanical engineers, we will work through the steps of the engineering design process. We will ask some questions, imagine some big ideas, plan our model, and then create it. Finally, we'll think about improvements to make it even better. So our problem is to reduce the amount of space needed to capture wind energy. And our solution is to build a prototype of a vertical wind turbine that is smaller and more efficient than the traditional turbines. So first step is asking questions. And we're going to go through this as we become a mechanical engineer. Are you wondering about the process and the product will help guide us through the next stages of imagining and planning? Do you have any questions about a vertical wind turbine? Here are some things that I'm wondering about. What materials are we going to use? How will the shape of the blades catch the most wind? How will we get the turbine to spin? And what if my design doesn't work? As we start the imagining step in the design process, we will start to answer some of these questions as we imagine what our vertical wind turbine will look like. If we use blades to catch the wind, how many should we have? What shape should they be? There are many options to choose from. Now that we've imagined different options, we can make our plan. Today, we are going to use two blades, and they're going to be half-cylinder shapes. We'll be using cardboard and tape for most of the main structure, but we'll need something to allow it to spin. I think a straw will probably work well to hold the blades and also spin. So here are the materials that we will need to build our vertical wind turbine. Shout out to the teachers who were able to find compostable straws. Way to be green. It's time to build. Remember, you can pause this video and you can restart it and when you're ready. So let's go ahead and check out our materials here. And what we're going to start with is the base of our wind turbine. So I'm going to kind of put our items off here so that I can work with my base structures. So first, let's go ahead and grab our piece of cardboard. It doesn't have to be exact this shape, but just kind of something similar to this. And what we're going to do first is we're going to cut our shape in half. So we're going to basically kind of draw a line, looks about there. It doesn't have to be perfect. And then please take your scissors and go ahead and cut your cardboard in half. Excellent. So now we have 2 pieces of cardboard. Again, they don't have to be perfect. They just need to be 2 separate pieces. Next, we're going to take our cup. And with the cup, we're going to go ahead and put it on one of our squares. We're going to be drawing a circle around the cup. So if I take my pen and I hold the cup down, I can trace around the cup lid with the pen to make sure that I get a circle. Again, it doesn't have to be perfect, just kind of a circular shape that's around the cup. Ta-da! There's our circle. Now we're going to cut out that circle. And the best way to kind of do a circle cut, which is kind of a challenge to do, is to kind of, for me, I like to hold one side and then start with my scissors on the other. So I'll kind of cut here and then I'll find that line. And we would rather make this circle bigger than smaller. So just cut on the outside of the circle line. Go slow. And as you cut, you kind of spin the cardboard. So if my thumb is in the middle, I can go ahead and cut outside the circle. There we go. And spin, spin, spin. Spin, 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 and almost done. And ta-da! We have our circle. This is going to be part of the base of the turbine. So now what we're going to do is we need a place for our straw to go through. So if you can take your cup, you're going to put a dot just kind of right in the middle. Oops, you can't really see that dot. There we go. So I put a little dot right in the middle of the cup. If it looks like good in the middle, or if you put it off to the side, just make one right in the middle. And then once you have it there, you're going to actually poke your pen through the hole. So I want you to poke your pen in the hole. I'll turn this off so you can see a little bit better. There's the hole. So I'm going to go ahead and poke it through, but I want you to poke it all the way through. So kind of poke, 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 poke. And then see how it's all the way through. I've made that hole through the center of the cup. And then kind of twist the pen to make sure that hole is nice and big enough for the straw. Okay, so then we'll pull out the pen and we've got our hole in the bottom of our cup. Now we're going to do the same thing with our circle. So here in the middle of the circle, it looks about right there. That look good to you? So go ahead and make a dot in the middle of your cardboard circle. And with this dot, now this one might be a little bit more challenging because it's not as easy as the cup, but stick with it, you can do it. So you're going to go ahead and put the tip of the pen and poke a hole there and just keep on pushing through. So push through, and here comes my pen right on through that and out the other side. Okay, and then twist, twist, twist so that you can make sure that it's nice and large for the straw. Excellent. So now we're kind of set up to be having our base are going to be these 3 structures right here is going to be the base of our wind turbine. Now we're going to go ahead and create the blades. And for this, we're going to need a toilet paper tube. So here is our toilet paper tube. With the toilet paper tube, we're going to be cutting this in half as well. So if you put it to the side and just cut a straight slit right up the side of it. You can make a line if you want to first that you want to follow, but basically you're going to just cut it right down the middle on this side. Then if you kind of open it up a little bit, or you can go this way and you want to kind of make a mark just opposite of that slit, maybe like right over here. And that tells me, okay, I'm going to actually cut the other side as well. So you want to cut the whole toilet paper tube basically in half. So there's that side. And now I'm going to cut another straight line down the center. So we're ending up with our toilet paper being cut in half, just like this. Got it? So these are going to be the blades of our wind turbine. And we have to attach them to the straw, right? So we have our compostable straws here. Grab one of these. And in order to make the blades, we're going to turn this one upside down. So we're going to be taping the straw to the inside of our toilet paper tube, of half of it. Now what I like you to do is just kind of put your finger so there's a little bit of space at the top. And then we're going to need a piece of tape to be able to put that right along the edge of the cardboard. And we're going to tape it to the top like this. Okay, so we got one piece of tape at the top there. I'm also going to go ahead and put a piece of tape at the bottom as well, right here. Okay, so we have two pieces of tape that have secured our straw with a little bit of space at the top here. And we're going to be able to have half of our blade with that shape ready to go. So now let's go ahead and take our other half of our toilet paper tube and we're going to put it right on top. So this time we're going to put it this direction. So now we're going to kind of hook it so it's going to look like this after we've got it taped. See how it kind of makes a little S shape like this. So if you put it almost like it's back in its toilet paper form, you're going to slide it to the side, and now we're going to secure it with tape here as well. So we're going to go ahead and put a piece of tape up here at the top and put a piece of tape here at the bottom. All right, and we want to make it even a little bit more secure. So I'm going to turn it over and we can have our shape here, but I want us to put one or two pieces of tape on this side as well, just to make sure that it's nice and secure. On this side as well. There we go. All right, so these are our blades, and you can see how if I take the bottom of them, it's going to be able to hopefully spin and capture that wind energy. So let's attach it to the base. So what we're going to do first is we're going to take that cup and we're going to poke the straw through the hole in the cup. All right, and once we have it, we can kind of lay it down. And now we're going to go ahead and put the hole through the cardboard as well. Okay, so if you lay it down, it's a little bit easier to do that. Now that we have it like that, we're going to secure the cardboard base to the cup with a piece of tape here. And maybe one on the other side as well. If we spin it, we can do it on the other side as well. Okay. We're almost there. Now we're going to attach it to the base part right here. So make sure that the straw stays out here. And I'm going to put this right in the middle. And then I'm just going to set the straw down. Okay. So the straw is still kind of out a little bit on the bottom. It's right in that hole still. So it's going to sit nicely right at the bottom of our, oops, mine came out. Let's go put it back through. If you need to take the cup off to be able to redo it, it's okay. But there's mine. So now we've got that shape ready to go. All right, so now we're going to go ahead and tape this to the bottom of our base. So I'm going to take one piece of tape and place it on the base right here from the cup. That one didn't work, so let me try another one. bigger one. There we go. Now that's secure. And let's do this as well. This side. All right, now that is nice and secure. And we have created a vertical wind turbine. Well done. Let me add a little bit more tape for reinforcement here and here. So if you have a fan available, it would be awesome to be able to test it with a fan. But if you don't, you can also just take the top and see how it's going to spin, right? Oops, we need to make sure that it's in that hole. There we go. So it's going to spin. We'll see that happening here. So what we're going to do now, I actually do have a fan. So I'm going to go ahead and bring it on over here. And I'm going to turn it on and see if it's going to be able to capture the wind energy. So here we go. Let's see if it's going to work. Ooh, I think it's starting. Here it goes. Ooh, maybe a little bit more wind. How about that? Look it go! It's spinning. See how the wind is turning the blades? That's the energy that's going to get changed into electricity. Awesome. This is going to reduce the amount of energy it takes to capture and convert wind energy into electrical energy. Thanks, fish. That is awesome. All right, my friends. So we were able to build and test our awesome wind turbine. Now, are there any improvements that you would like to make? Does yours work like it should? Does the wind make it spin properly, or did it kind of wobble a little bit? Would you like to use any other materials if you could make another one? What improvements would you make if you were going to build another vertical wind turbine? Go ahead and put your improvement ideas into the question and answer section. I'll check back and hear your amazing ideas soon. We did it! We became ichthyologists and learned some of the amazing abilities of fish and some of the innovative products that they have inspired. We learned about wind energy and became mechanical engineers and built a vertical wind turbine. Now it's time to put our knowledge to the test with a Kahoot. Please go ahead and enter this pin into a separate window or device so you can play along. So Mr. Bruder, while I'm getting this kind of worked out here, I think this would be a great time for us to hear about some animals that they know of that live in groups. And I'd love to hear any of their ideas about improving their vertical wind turbines as well.
Hey, Mrs. Q, you know, I have to ask you, before I share those, can we ask you a couple questions from our viewers?
Absolutely.
One of the questions they had was, how does shark skin work? Like, how does it not stick to the barnacles?
Oh, isn't that amazing? So smooth surfaces are what barnacles need. They do gotta go on rocks, but it makes it harder. So when the boats are very, very smooth, it's super easy for the barnacles and other animals to attach. So by having those ridges, so when we looked at that picture that was up close on the skin, it looked like they were kind of bumpy. And that's what prevents the barnacles from attaching. So those ridges, and it almost, when you touch the skin of a shark, it feels almost like sandpaper. It's kind of got a smooth one way, but then it's kind of pokey and kind of grainy in the other direction. So having that kind of bumpiness surface is what prevents bacteria from collecting on like hospital surfaces and also on the boats as well. So being smooth is not a good thing in the ocean if you don't want to attach barnacles.
Very cool. Another question was, why do sharks lose their teeth?
Oh, well, the problem with sharks is their teeth are not hooked in as well as ours, but it actually isn't a problem for them because they can regrow them to replace it, right? So if they had teeth that were like ours, maybe they wouldn't need to, but they are constant. Remember, they don't have hands, they don't have knives and forks to cut up their food. So their teeth break. So even if they don't come out all the way, they're going to break when they're biting their food because that's all they have. They don't have hands or nets to catch their food. So their teeth get broken. And so if they break or if they fall out, that's going to make sure that they then can regrow and always have a perfect set of teeth. Does that make sense? Hopefully.
I think so. We have another viewer who absolutely loved the baby horn shark and had another question specifically about you. What interested you in this job that you do?
Oh, wow. That is an awesome question. Well, in my high school class, I really was obsessed with physiology, which is how the body works. So how all of your insides work together. So I got really interested in science. So I went and I had my degree in physiology, and then I also really loved teaching kids. So I was lucky enough to find this position where I went and I got my teaching credential, and then I got my, I had my credential in science as well. And so then those combined allowed me to be able to work in this amazing place where I both get to work with animals and with kids. So I am very, very lucky.
Thank you so much for sharing that. And speaking of that, Mrs. Q, I know that you also introduced your students to careers in science. So I have to share with you that one of our viewers, Chloe, shared that when she grows up, wants to be a marine biologist.
Yay! That's so wonderful. Marine biology is such an amazing field. There are so many wonderful things in the ocean, and hopefully you'll think about biomimicry as a wonderful person in the future with that career as a marine biologist, because you'll be studying about a lot of animals and they have inspiring abilities.
Well, thank you for answering those questions. I know I owe you some answers about the question about other animals that live together in groups. So Chloe had shared wolves, Emily shared birds, Aaron mentioned monkeys, another group of people mentioned deer, elephants, zebras, all kinds of stuff.
Are we starting to see pretty much every kind of animal? Reptiles, mammals, fish, right? Invertebrates. There are quite a few different types of animals that actually live in groups because it's so successful for them to be able to kind of hang out together. And people too, we like to hang out together as well. Very cool.
There so many great answers on that one. So I see that our Kahoot is, as far as more people joining, is slowing down. So I think we're ready to get going with that.
Let's do it. Absolutely. Sounds great. All right, let's go ahead and get started. Innovation inspired by nature in 3, 2, 1. First question. Biomimicry is solving problems by looking at red triangle, light, blue diamond, nature, yellow circle, cars, or green square, moon. Biomimicry is solving problems by looking at red triangle, light, blue diamond, nature, yellow circle, cars, or green square, moon. What is biomimicry? Biomimicry, think about what we talked about, is solving problems by looking at light, red triangle, nature, blue diamond, cars, yellow circle, or moon, green square. About 5 more seconds, get your answers in. And the answer is nature. Fantastic. We look at nature in order to solve problems. That's what biomimicry is. Here we go, number 2. Oh, we gotta check out who is in the top here. Daring yak, awesome frog, kind hawk, inspired glider, and glowing bat. Well done. Keep it up, keep it up. Here we go, question number 2. What fish body part inspired car companies? Teeth is red triangle, blue diamond is swim bladder, yellow circles body shape, or green square skin. What was the body part of a fish that inspired the car companies? Was it red triangle teeth, blue diamond swim bladder, yellow circle body shape, or green square skin? What do you think? What was going to inspire engineers? Which fish body part? Red triangle is teeth, blue diamond is swim bladder, yellow circle is body shape, and green square is skin. About 5 more seconds to get your answers in. And the answer is body shape. Well done. You rocked that one. Excellent, excellent. Absolutely. Body shape is what inspired the car companies Chevy and Mercedes. Kind Hawk moves into first. Inspired glider, focused lemming, awesome frog, and epic hamster. Well done, everyone. You are rocking this. Next one is, ooh, and glad squid. You just jumped 30 spaces. Number 3, a horn shark uses its sharp spines to, red triangle, eat, blue diamond, swim, yellow circle, breathe, or green square, protect itself. Horn shark uses its sharp spines to eat, red triangle, blue diamond, swim, yellow circle, breathe, or green square, protect itself. Remember our little baby. Wasn't he so, or he or she, so cute? We're so excited to have it here. So what do you think? Those sharp spines on its fins were going to inspire, or they are going to help him to eat, swim, breathe, or protect itself. 5 more seconds. Get them on in. And woohoo! Protect itself. Well done, friends. You are doing so well. Let's see who got their answer in quick on this one. Kind Hawk got a quick fingers there with 2,870 points. Well done. Epic Hamster hanging in there. So is Focused Lemming, Daring Yak, and Helpful Gator. Welcome to the board. And Captain Falcon, woohoo, 37 places that time. Here we go. What inspired a vertical wind turbine? What inspired a vertical wind turbine? Red triangle, schooling fish. Blue diamond, jumping rabbits. Yellow circle, flying bats. Green square, running lizards. What inspired a vertical wind turbine? Engineers were inspired by something in nature. It was red triangle, schooling fish, or was it blue diamond, jumping rabbits, or yellow circle, flying bats, or green square, running lizards? What inspired the vertical wind turbine that we created as mechanical engineers? What do you think? Schooling fish, jumping rabbits, flying bats, running lizards. Almost out of time. Yes, schooling fish is correct. Well done. Ooh, oh, Kind Hawk hanging in there. Well done. So is Focused Lemming, Cute Lemur, welcome to the board. Melodic Macaw and Soaring Tiger, well done. 16 players have answered. Oh my goodness, 3 in a row. Well done, friends. Okay, here we go. Last question. A person who designs machines and technologies is a, what are they called? Red triangle, mechanical engineer. Blue diamond, ichthyologist. Yellow circle, chemical engineer. Or green square, herpetologist. A person who designs machines and technologies is a red triangle, mechanical engineer. Blue diamond, ichthyologist. Yellow circle, chemical engineer. Or green square, herpetologist. What did you become today? What career did you take on when we built the vertical wind turbine? Were you red triangle, mechanical engineer, blue diamond, ichthyologist, yellow circle, chemical engineer, or blue square, herpetologist? 5 more seconds. Get your answers in. The answer is mechanical engineer. Woohoo! Absolutely. Well done, mechanical engineers. So let's see who's on the podium. Woohoo! With 3,854 points, Kind Hawk. Well done. Number 2, Jolly Gecko jumped up. And number 1 with 3,977 was Focused Lemming. Well done, everyone. Cute lemur and looks like magic. Something I can't see your name. Well done as well. I'm super impressed how well everyone did on this Kahoot. Excellent. All right, so I hope you enjoyed meeting our baby shark today and learning how fish have inspired some fantastic inventions. If you want to see more of our animal ambassadors, you can check out my Creature Close-Ups with Mrs. Q YouTube playlist. The link is being posted in the question and answer section now. And also, the Living Coast Discovery Center is open Thursday through Sunday now. So come and see our animal ambassadors in person. Also, if you've missed any of the previous live events, you can visit our Innovation and Instruction YouTube channel. You can find all of our previous events there and a ton of other resources as well. The link for this channel is being posted in the question and answer section now as well. I hope you enjoyed today's live event. Exciting news, in 2 weeks, on November 5th, Mr. Garcia from the Innovation Station will be presenting his live event titled Computer Coding Graphic Designs. This will be a hands-on, interactive experience, so don't miss it. Thanks again for attending. Bye.